Hello everyone, welcome to this series of lectures. My name is Eugene Bazangoli and I'll be your facilitator for the programming and problem solving class. In today's day and age, a lot of students in the universities are taking programming related courses. With this, you realize that throughout your stay in the university, you will take a number of programming courses. This makes students to believe that to be a good programmer, you should be able to just jump in once you are given a problem and start typing out codes. That's a fallacy. To be a good programmer, you should be able to follow a scientific way of solving that problem. And one of the ways of solving that problem is designing a solution that will stand the test of time. In this series of lectures, we will look at how to properly design your solutions for a given problem. Take some time to pause and subscribe to this channel. If you have any questions, put it in the comments below and I'll do my best to respond to it. Thank you. In today's lecture, we will be looking at programming and problem solving. In this particular series, we would look at how to develop your solutions using pseudocode. Pseudocode is not a specific programming language. However, it is simplified English which we'll be using to help you develop your solutions properly. Think of it as a cadet corps who is given a wooden rifle to learn how to handle the rifle properly before you are actually given an AK-47 to go into battle. Today we are looking at program design, and by the end of this lecture, we should be able to describe the steps in a program development process. We should also be able to introduce the current program design methodology. Again, we should be able to introduce procedural and object-oriented programming. We should introduce you to algorithm and what pseudocodes are. And by the end of this lecture, we should also be able to look at what is program data. Programming can be defined as the development of a solution to an identified problem. When directed through a computer hardware, this solution should produce the desired results. So this is computer programming. But programming in itself is an art. Why do I say programming is an art? Like I mentioned in the introduction, many programmers believe that to be a good programmer, you should be good in mathematics, you should be good in handling figures, you should have some technical information, and you should be able to spend a lot of hours sitting at your computer typing out programs. However, given the right tools and steps to follow, anyone can write a well-designed program. It is a task that's worth doing. It is stimulating and it is very fulfilling if you do it right. So, to be able to write correct programs, you should not just be looking at being able to churn out figures and being too technical. There is the need for you to use the right tools and steps in program development. When we talk about the right tools and steps, what are they? Programming involves the designing of a solution to an identified problem. The designing of the solution is very, very critical. This is a step that a lot of programmers ignore, but this is a step that a lot of very good programmers practice properly and have the desired results. So, to be able to develop a program, you need to go through some steps. The first step is you should be able to define the problem. Once you are given a problem to solve, you should be able to define the problem. Then you should be able to outline a solution to that problem. That is, after defining the problem, you should be able to outline a solution to that problem. It is after you have outlined a solution to that problem that you now develop outlines for your algorithm. Then, after outlining your algorithm, you need to even test the correctness of the algorithm that you have outlined. After testing the correctness of the algorithm, this is where you put in data to make sure that what you think the solution should be should actually give you the desired results. It is only after testing the correctness of your algorithm that you should now start typing codes. Once you type these codes, you run it on a computer, and then after running it on a computer, you realize that everything is working as expected. You should be able to document and maintain your program. So you see that writing a program is not a one-off solution, but then it is a 7-step approach, which if you follow religiously would help you come up with the desired results. Okay, so let us recap the 7 steps that are involved in program development. We said for you to successfully develop any program, you need to go through these 7 steps. The first one is being able to define a problem. To be able to define a problem, you need to break your problem into inputs, outputs, and the processes to produce the required output. With this, you can use a definition diagram. We will talk more about definition diagrams when we dive into problem definition. Secondly, you should be able to outline a solution for your problem. Once the problem has been defined, you need to be able to identify the major processing steps involved, the major subtasks if there are any, the user interfaces if there are any, the major control structures such as selection and repetition. If you don't know what they are, relax, we will talk more about them. You should also be able to identify major variables and record structures, and then be able to have your mainline logic. All of this is what will constitute the solution to your problem. After outlining your solution to your problem, you need to develop an outline for your algorithm. That is, further developing step 2 into simple, concise instruction that anyone can follow and be able to find a solution to your problem. So, after defining the problem, the next thing you do is to outline a solution. After outlining your solution, you now have to develop your algorithm. After developing the algorithm, you then test the algorithm for correctness. This is taking sample data, inputting those sample data into your logic, and look or examine the outcome if it is the desired outcome. This is what we refer to as you testing your algorithm for correctness. Then we also mentioned that after testing your algorithm for correctness, the next thing you do is to code the algorithm into a specific programming language. This is where most of it starts from, but this is actually the 5th step when developing your program. After coding in a specific language, you run your program on a computer, and then you now document and maintain the program. Maintaining your program is handling the changes that may come along the way until the lifetime of the program is exhausted. These are the 7 steps that we need to follow in developing our program. If you have any questions, please put it in the comment section below and I'll do well to answer them. Let us talk about program design methodologies. The fundamental principle of designing a program is based on the fact that a program must accept input data, process that data, and then deliver the data to the program user as output. There are different approaches that are used in designing a program. Three of the approaches will be considered or will be discussed in this particular lecture. First one is the procedure-driven approach. We will talk about the event-driven approach, and then we will discuss the data-driven approach. What is a procedure-driven approach? In the procedure-driven approach, the program design is based on the idea that the most important feature of a program is what it does. That is its processes or functions. By concentrating on what a program does, you would realize that the programmer identifies and organizes the processes in a program solution. The flow of data in and out of each process or function is then considered, and a strategy is developed to break each of these functions into smaller and very specific flow of data. What do we mean? The details about the actual structure of data will only be considered after a high-level process or function of the program has been defined. So you see that in this particular approach, all the concentration is given to what the program should actually do, what functions the program should actually be able to perform before that of the data is considered. This approach of designing a program is what we call the procedure-driven approach. The next approach we'll be talking about is the event-driven approach. In the event-driven approach, you realize that the program design will be based on the idea that an event or an interaction with the outside world can cause a program to change from one known state to another. You realize that the initial state of a program is identified. Then all the triggers that represent the valid events for the state are established. So we will start with one state. We would identify all the different states that the program can assume. And then we will develop around those states. And so whenever there is a trigger, you realize that the trigger will represent a valid event. Let us take a program where the user decides to right-click on a particular button. A different action will be triggered. The same way, that same program, when the user decides to left-click, another different action or another different state will be triggered. So you see that the program's behavior will depend on which action or which state is triggered by the user. Whether the user is right-clicking, whether the user is left-clicking, whether the user is dragging, all of this will trigger a different response. And so with this approach of program design, it is based on the user's action, and then some states would be triggered. Then we have the final state, which is what? Data-driven approach. What is a data-driven approach to program design? In a data-driven approach, the designer assumes that the data of a program is more stable over the process. What do we mean by this? Before the programmer designs a program using a data-driven approach, the programmer would analyze all the data that is required and all the data that is supposed to be given out at the end of the day. And once the program has been able to establish which data has to be given back to the user, then the programmer would now look at all the processes that can convert the input into the output. So you see that the programmer is more focused on the data and the data structures that are involved before the final process that is used to convert that initial data into a final product is established. But in all of these three approaches that we have seen, you would realize that whether you choose the procedure-driven approach, the data-driven approach, or the event-driven approach, it is mainly dependent on which programming language you are using. And once you start using different programming languages, you would appreciate the different approaches that are being used in program design. Since the development or the choice of the different approaches is based on programming language, it is better to develop your basic skills in designing a solution. And once that basic skills have been developed, the choice of whether it is a procedure-driven, event-driven, or data-driven approach would not actually matter. And all of it would, using the right approach or using the right language, you would have a good program. So far, we have looked at the different steps that are involved in program development. We said there are 7 different steps that are involved in program development. We have also discussed the different approaches that you can use in designing your program. So, if you do not understand anything at this point, or if you cannot remember, I suggest you pause, rewind, and then understand each of the steps within the program development process, and then also try and understand the approaches that are used in program design. In your programming lifetime, there are 2 terms that you hear frequently: procedural programming and object-oriented programming. What is procedural programming? In procedural programming, the code is based on a structure. That is a top-down approach to writing effective programs. The approach concentrates on what a program has to do, and it involves identifying and organizing the processes in the program solution. The problem is usually broken down into separate tasks and functions and includes top-down development and modular design. Now, let's look at what we mean by top-down development. In top-down development or program design, the general solution to the problem is outlined first. You would realize that this outline is then divided gradually into more detailed steps until finally the most detailed levels are completed. It is only after this process of top-down development that the programmer starts to code. The result is a systematic, disciplined approach to program design. The result of this systematic, disciplined program design is a higher precision to programming than was previously possible. In the case of object-oriented programming, the program is broken down into objects. Emphasis is placed on what the object can do or the behavior of the object with definite properties and related tasks are grouped together. So for instance, if I'm developing a program for a school management system, right? Then I would look at what objects can be involved in a school management system. So for instance, one of the objects would be a student. I would then look at the behavior of a student within the program context. So I know a student, for instance, should be able to check his results. A student should be able to pay fees. A student should be able to register his courses. These are behaviors that are possible for a student. And so these behaviors are grouped together, and then the relation between them are organized. Most often, when you are writing your program, you would merge these two approaches. You will use both procedural and object-oriented programming in your design. And so, what again you should focus on is developing your basic skills. All of these other things would come naturally as you grow within your programming career. At the end of this lecture, we have looked at the different program design methodologies. We said there are three main design methodologies: the procedure-driven, the event-driven, and then the data-driven approaches. We also looked at the different steps that are involved in your program design. We said you first have to define the problem, you have to outline the solution, you have to develop your algorithm, test that algorithm, run your code, write your code, run your code, and then document and maintain your program. We also looked at procedural and object-oriented programming. We said the procedural involves a top-down approach and a modular design. We also have object-oriented programming that focuses on breaking down programs into objects and how those objects relate to each other. If you have any questions, put the questions in the comment section below and I would answer. Again, I would encourage all of you to subscribe to this channel for related contents. Thank you.